Every single day, we trust tons of websites and apps with pretty much everything. Our private messages, our photos, even our money. But behind those shiny, user-friendly screens, there are hidden dangers. Little cracks in the armor that attackers are just waiting to find. So let's dive in and uncover the web's most wanted list of security threats.
So let's just start with the biggest question on everyone's mind. When you hear about some massive data breach in the news, what do you imagine? Probably some super genius hacker in a dark room typing away at lightning speed with green code flying across the screen, right? Well, what if I told you that's almost never how it actually goes down?
Yeah, the reality is, it's usually a lot less like a movie. It's less about some brilliant, never-before-seen attack, and way more about exploiting really common, well-understood mistakes. Think of it less like trying to crack a super secure vault, and more like finding the key that somebody carelessly left under the doormat. These are known issues, and just understanding what they are is the first huge step to defending against them. Now, to help us wrap our heads around these common problems, we're going to turn to the experts. There's an organization out there that basically publishes a most wanted list for web security risks, and they're going to be our guide for this whole explainer. And that organization is called the Open Web Application Security Project, or just OWASP for short. They're a nonprofit, and their entire mission is to make software safer for all of us. Their most famous creation is the OWASP Top 10. It's a list they update every few years that flags the absolute most critical security risks out there. It's basically the gold standard in the industry, and we're going to use it to profile our top culprits.
All right, let's open up our first case file, deception. This whole category is about tricking a web application into doing something it was never, ever supposed to do.
This is what we call an injection attack. Okay, imagine you're at a login screen. You're supposed to type in your username, but instead, an attacker types in a tricky line of code that basically says, oh, and by the way, also show me the entire list of user passwords. If the website isn't smart enough to catch this trick, its database might just obey that hidden command. And just like that, the attacker gets everything. That's the whole idea behind injection, sneaking malicious instructions right past the guard.
Next up on the list, let's talk about the crime of impersonation. Now, this isn't about fooling the system with clever code. This is about stealing someone else's digital keys and just waltzing right in through the front door.
This one's called broken authentication. See, when you log into a site, it gives your web browser a kind of temporary hall pass, usually called a session cookie. It's what keeps you logged in as you click from page to page. Well, if an attacker can somehow steal that session cookie, they can pretend to be you without ever needing your password. It's literally the digital version of someone snatching your VIP wristband at a concert to get backstage. And you know what? This is where our own bad habits can really come back to bite us. Reusing passwords is what leads to this incredibly common attack called credential stuffing. This is when attackers get their hands on a huge list of usernames and passwords from a data breach at one company, let's say some social media site. And then they use bots to try those exact same logins on thousands of other websites, like your bank, your email, you name it. This diagram shows you exactly how it works. Look over on the left. The attacker starts with a massive list of stolen login details from some other company's breach. Then, in the middle, you see the bots. It's like an automated army, just hammering away, trying every single one of those stolen combos against a completely different service on the right. It's just a numbers game, and it works depressingly often because so many people use the same password for everything. So it really boils down to this simple three-step playbook. First, they get the data, which is sadly pretty easy these days. Second, they automate the process so they can try millions of logins without breaking a sweat. And third, they exploit any hits they get. This simple process is exactly why security experts are always telling you to use a unique password for every single account. It's one of the best defenses you have.
All right, let's keep moving. Our next case isn't really about breaking in or stealing keys. It's about what happens when you find out the doors were never even locked to begin with.
This vulnerability has a name, broken access control. Check out this diagram. A user asks for their own file, document 1000, and the system says, sure, here you go. But then, just for kicks, they try asking for document 1002, which belongs to someone else. A secure system should immediately say, nope, access denied. But this one just says, no problem, here you go, and hands over the file. This kind of thing happens all the time when a website forgets to check if you actually have permission to see what you're asking for. Another type of trespassing is when your data gets exposed while it's in transit. This is often called sensitive data exposure. And a classic example is the man-in-the-middle attack. You see it right here. The user thinks they're talking directly and securely to the website, but an attacker has secretly wedged themselves in between, listening to and reading everything that goes back and forth. This is a huge risk on unsecured networks, like the Wi-Fi at a coffee shop, if your connection isn't properly encrypted. Okay, our final case file covers a whole group of issues that honestly usually just come down to simple negligence. Things like using out-of-date software, forgetting to lock things down, or just leaving obvious holes for attackers to slip right through. And this right here is a perfect, real-world example of security misconfiguration. What you're looking at are the settings for a cloud storage bucket. And notice that big, obvious checkbox, block all public access. You would not believe how many massive data breaches have happened simply because someone forgot to check this one little box, leaving gigabytes of sensitive data wide open for anyone on the internet to find. Sometimes security really is that simple. Another one of these common gaps is cross-site scripting, or XSS. Now, there are two main types. The first is reflected XSS. That's kind of temporary. An attacker creates a special malicious link, and when you click on it, a script runs on your browser. But stored XSS, that's much scarier. That's when an attacker manages to get their malicious script saved on the website itself, maybe hidden in a comment on a blog post. Now, every single person who visits that page unknowingly runs that script, which could easily steal their session cookie, their backstage pass, and send it straight to the attacker. And finally, we have the gigantic problem of using components with known vulnerabilities. See, modern websites are built like they're made of Legos. They use all sorts of third-party tools and libraries. But what happens if one of those Lego bricks has a known crack in it? Well, attackers are constantly scanning the entire internet for anyone using that one flawed piece. This map here from a search engine called Shodan shows over 1.8 million devices that are potentially vulnerable on just a single port. The scale of this problem is just staggering. So, after looking through all these different cases, from deception and impersonation to just plain negligence, what's the big picture here? What's the main thing you should be taking away from all of this? It's this: hacking isn't magic. Most of the time, it's not some unstoppable force. It's just attackers following a playbook, exploiting a known list of common, predictable, and frankly preventable problems. That OWASP top 10 list isn't just for coders. It's a way for all of us to understand that web security isn't automatic. It's something that needs constant care and attention. And that really just leaves us with one final question to think about. Everything we've talked about here applies to every piece of software you use. So think about all those apps on your phone, all the websites you visit every day. How many of their digital doors do you think are actually locked? And how many were just left wide open, waiting for someone to walk through?